Okay, this the last part of uh, lecture number 9. But first, let me give you this answer to the break exercise. Okay, remember we said if you assume light has a gravitational mass, and which should be, we argue, should be equal E over c squared, then also because E is proportional to frequency, then from this we can derive the uh, gravitational redshift formula from assuming light has a gravitational mass. A step goes like this. We have energy conservation, so the change in kinetic energy plus potential energy equals zero. So therefore, if I substitute the gravitational mass into the uh, potential energy term, so therefore this is delta E plus E delta F over c squared. So therefore we have delta E over E equal to minus delta gravitational potential over c squared. Then of course substitute E as proportional to frequency. So that for the left hand side, simply the fractional change of frequency equal to minus the change in potential over c squared, which is the gravitational redshift result. Okay, so anyways, we have assumed gravitational mass, and then it will allow us to use energy conservation to derive the uh, redshift result. It's very simple, but it turns out we say it's not a correct way to think about, you know, to think the light has a gravitational mass, uh, because as I said, we're assuming that the light has some sort of no, some sort of non-relative mass for the light particle, but photon is massless. There's never a non-relative particle, and also this derivation, while it's simple, makes no connection to the underlying physics of gravitational time dilation, and uh, so doesn't fit the overall picture of the uh, equivalence principle and the GR. So then it's what is the correct way of looking at the uh, energy transmission in gravitational field? Uh, First of all, light is emitted and received through the atomic transitions, to level emitting or absorbing a frequency equal to h bar omega. Now, atoms are non-relative, can be treated as non-relative massive objects. So therefore, a receiver sitting at a higher ground potential will have energy different from the emitter level by mgh. H is the high difference, and g gravitational acceleration, and m, of course, is the atomic mass, which can be treated as gravitational mass. So now if we replace now by m by e with c squared, so this becomes e, and I can factor e on the right hand side. So therefore, the received energy level differs from the emitting energy level by this factor. So it's higher because it's greater than 1. So therefore, all the energy levels of receiver uh, and therefore all the differences are multiplicably blue shifted because this is bigger than 1 factor. Okay, so again, the energy level of the receiver atom compares the energy level of the emitting atom, all the levels, and therefore the differences are all blue shifted. Blue shifted. Now, when a light, so just so this is the so we have the fractional change of the, which means I'm talking about the amount shift is given by the second term here. So therefore, the shift, fractional change shift, is equal to gh over c squared, which can be written more generally as delta phi over h squared. Okay, so the atomic level are all shifted. So therefore, the uh, atomic level differences are shifted. So, so if the energy atomic level shifts, but the travel light pulse arrive the receiver with the same energy, and it'll be. But on the other hand, even though it arrives the same energy, it'll be seen by the atom as receiver as redshift because the receiver level have blue shifted. So therefore, the light will appear to the atom to be uh, redshifted by the amount, of course, just the opposite of this. So it's minus delta phi over c squared. And then for delta E over E is delta omega over omega. So therefore, this is just the gravitational redshift result. Okay. So the point is that the light have not changed energy, but because the device receiving it has shifted energy levels, therefore the light appears to be redshifted. And if this is correct, remember we talked previously with assigning a gravitational mass of light has problems, but in this case here, the atom, of course, can be treated as non-relative object having gravitational energy and gravitational mass. And also, this derivation is entirely consistent with gravitational time dilation because the frequency shift comes about because the standard time, which is ultimately set by the frequency of the atom. In other words, the atom is sometimes the most basic form of clock, has the physical picture of clock must run at different rates at different gravitational potentials because energy level is shifted. Uh, Before we finish, let me give you another warning about something. When there are different things being called Newtonian result. Remember, we talked about the light deflection. The diffraction angle is Newtonian result. What it means is this really means the pre Einstein relativity results, which in that case the particle can travel any speed it wants to. So this Newtonian mechanical results applied to light give you the angle of deflection this way. This is not to be confused with later on we'll have the GR theory of gravity, okay, relativity theory of gravity. In that case, there we can take the when a particle either travel at a non-relative speed, or also the gravity field is weak or time independent. Okay. The point is that the Newtonian limit of GR is not from Newton's rule, like we talked about pre-relativistic. Okay, they are different. Maybe I should say Newtonian limit is not equal to pre-relativistic. Uh, Now, Einstein's equivalent principle play a role to allows him to construct a theory of general relativity, which is the geometric theory of gravity. And of course, we have shown equivalent principle allows us to uh, uh, to have the accelerated frame to treat on this equal footing as inertial frame, which is inertial frame with gravity. So this gives us an early glimpse of the GR phenomenology. And also, while we're going to the point we want to make is that equivalent principle of physics, for example, the gravitational time dilation, implies, as we will show, that gravity is the structure of curved space and time. Okay. And also because equivalent principle allows to cancel the mass factors in the equation of motion, so therefore the resultant gravitational equation of motion is totally independent of any property of test particles. And this independence suggests to Einstein that the gravitational field, unlike the other force fields, is related to some basic feature of space and time, in fact, to the curvature of space and time. So, in order to talk about curvatures, curved space and time, so starting next lecture, we're going to spend some time talking the mathematics of the curved space, the mathematical description of curved space.